Let us quickly go through the language of functions. So some of you may be familiar with this, but a function y equals to x squared, where x is any real number, that's a function. It's a mapping. It's an operation. It's what you're telling someone to do to x. You're telling them take x, make it x squared, and produce a result, and that result is y. But there are just so many other ways of writing a function. You can write it as y equals to x squared, as I have here, or you can say f of x equals to x squared. This is just another way of writing a function. Or you can say f maps x onto x squared. So it's like an operator box here that does this squared, where take x, let's say x equals to 2, put it in the operator box. 2 squared is 4, produce a result. The result will be 4. So your y would be equals to 4. Now, usually functions are written and there's also a domain written. And domain are the values of x that can work with the function. So here x is a member of any real number. X is any real number. So it could be any number from minus infinity to infinity. Now, we can plot x squared, but we will do that in a little while because this is important. It is important. So minus infinity this side, positive infinity this side, well, it's just x. But it can take all of these values and you can draw y equals to x squared here. Let us talk about the inverse function for a second. This is something important here to remember in this topic. Inverse function and how do you calculate it? Let's use this example here. So we have our OG function, our original function, where f of x equals to x squared. What's important is, first of all, just write it in the other way, the other term of y equals to x squared. This is just another way of writing the same function. And then switch x and y, so that instead of writing here y, we write here x, and instead of writing here x, we write here y. So this is switching x and y. Then after this, make y the subject so that it looks like your typical function. So root of x equals to y. So y equals to positive or negative root of x. Well, so what are the domain and what is the domain of this new function, of this inverse function? Well, let's have a look at the graphs as I wanted to do that in the beginning. So if we have here x squared, and it's good just to plot them on the same graph and the same scale. So this is x, this is y. So what I've drawn here is y equals to x squared. Now remember, you can draw root of x as a function if you think of it as, well, if this is y equals to x squared, root of x minus y, how do I draw this? What helps me remember is that here y squared equals to x. So this has to be a smiley face, but the smiley face is such that my x-axis is now the y-axis, if you see what I mean. So how that will look like is if I imagine, or if I flip my page, it's such that this is now my y-axis and this is now my x-axis. So it looks like this. It's a smiley face in this direction. But then let's get back to it. So what I've just drawn here is y equals to root x. But why is this not a function? Well, it's not a function because we've got values of x here that are producing two values of y, and that is not the definition of a function. Remember I said it's a mapping that's a one-to-one function, one-to-one mapping, or a many values of x to one value of y. So to make it into a function, I only have to keep one side, so this positive side here. So it's not positive or negative root of x, and the domain for this function is x is greater or equal to 0. It doesn't take x's all real numbers like it did. But what about the range now? Let us talk about range. Well, beforehand, when I had y equals to x squared, what was the range? Well, the range here was y is greater or equal to 0. That was the range. It was all values at the top part of this x-axis. But what happens now? Well, the range now, well, y cannot be negative because y can't be negative because that makes it it doesn't make it a function. So the range is y is also greater or equal to 0. But you see what has happened is that initially our range is what now our domain is. And in fact, this is key because when we did this switch here, we were basically saying make y equals to x, right? We were reflecting it about the line y equals to x, and that's what an inverse function is. It is a reflection of a function along this mirror. So these values here and these values here are mirror images of each other. They're far away from the y equals to x line. So yeah, and that's all you need to remember.